Hello students, hello everyone and welcome to your channel NCERT Solution. In this channel, you will get answer for all your NCERT questions explained in detail. So please like, share and subscribe and share it with your friends so that even they get to know how to solve these NCERT questions. So let us quickly get started with the first question of your NCERT exercise of the chapter Relation and Functions. I hope by this time all of you know what is relation and functions and what are the different concepts you have been studying in that. So first question, determine whether each of the following relations are reflexive, symmetric and transitive. So children, you know already what do you mean by reflexive, symmetric and transitive, correct? If a given relation has to be reflexive, then the element A which belongs to the set A should satisfy a relation, that is A comma A must belong to set R, right children? This is the condition where you can call a function to be reflexive. And let us see what is symmetric. You can call a function to be symmetric when children, when can you call a function to be symmetric? You can call a function to be symmetric if A comma B, that is element A and B belongs to set A, and in the set B you have A comma B and B comma A. Yes, if you have A comma B and B comma A belonging to set A, then you call this relation to be symmetric. When do you call a relation to be transitive? Now just observe here, when do you call them transitive? Now it's about three elements, children. What are the three elements? If you have elements A, comma B, comma C, which belongs to set A, then it should satisfy the condition A, comma B should belong to R, should obey the relation. B, comma A, B, comma C should obey the relation. Yes. So A comma B belongs to R and B comma C also belongs to R and A comma C also belongs to R. Yes, A comma C belongs to R. In that case, you call this relation what? Symmetric, reflexive, symmetric and transitive. So if this condition is obeyed, you call them reflexive. If this condition is obeyed, you call them symmetric. If this condition is obeyed, you call them transitive. I think the relation about the basics of relation is clear, children. Now we are going to apply this in the questions now. So please try to understand because these are very important. Relation R. Let's go for the first question. So in the first question, children, they have given a relation. Okay, look at the relation. They're telling relation R in set A. So let us write set A. So in set A, they have given the elements. What are the elements? Elements are from 1 to 14. So elements are from 1, 2, 3, 4 and it's till 14. Okay, and they have given a relation R, x comma y, 3x minus y is 0. So R is given to us. What is R, children? X comma y, 3x minus y equal to 0. This is the relation given. Yes, try to understand. The relation is given in such a way that you need to select. They have given in set builder form. You need to write in the roster form in this way. How will you write? You will take the elements in such a way that it obeys 3x minus y equal to 0, which is nothing but 3x is equal to y. Choose the element, children, which obeys 3x is equal to y. What are the elements? I can take 1 comma 3. Yes, children, when x is 1, y is 3, right? Correct. 3 into 1. In the same way, you can select the elements 2 comma 6. You can select the elements 3 comma 9. You can select the elements 4 comma 12. Is 5 comma 15 possible? No, because 15 does not belong to set A. Yes or no? Yes. So we got our set R. Now let us check for the condition reflexive, symmetric and transitive. So I'll write reflexive here. So if you're checking for reflexive, children, just observe what the condition we studied first. Yes, what are the condition we studied first? We know that if it is reflexive, then A comma A should belong to R. Just check, is 1 comma 1 belonging to R? No. 1 comma 1, 2 comma 2, 3 comma 3, all those does not belong to R, right? So directly I'll write that does not belong to R. Hence, what we can write? Hence, not reflexive. Right, children? We can write hence not reflexive. Right? Now, if you're checking for symmetric, just observe here. Observe the given relation and observe what is the condition. What is the condition here, children? For it to be symmetric, tell me if it is symmetric. Yes, we know that. Take two elements, 1 comma 2, 1 comma 3. Let's take 1 comma 3. You know that 1 comma 3 belongs to R, but do you have 3 comma 1 belonging to the same set? No, we don't have 3 comma 1, correct? So 3 comma 1 does not belong to R. Similarly, you consider 2 comma 6, 6 comma 2 does not belong, 3 comma 9, 9 comma 3 does not belong, 4 comma 12, 12 comma 4 does not belong to set R. So what do you write? It is not symmetric. Yes, students? Understanding. Easy, simple. Now, let us check for transitive. When can this be transitive? Now, if you're checking for transitive, just observe here. What we can write here? Yes, if it is transitive, then 1 comma 3 should belong to R. And do you have any other elements? No, correct. 3 comma 9 you have. Okay, let us consider 3 comma 9 also belongs to R. So I can consider A comma B and B comma C here. But do you have 1 comma 9 belonging to R? No. So I will write 1 comma 9 does not belong to R, hence not transitive. So you call this not transitive. See children, any relation which is symmetric, reflexive and transitive is called an equivalence relation, and if all three are satisfied, then only you call it equivalence relation. Here it is neither reflexive nor symmetric nor transitive. Understanding, children? Is this clear? Yes, we have solved the first sub question under your NCERT exercise 1.1. Is that clear? Yes. So shall we go for the second sub question now? Look at the second sub question. The relation in the set n of natural numbers defined as r equal to x comma y, where y is equal to x plus 5, where x is less than 4. So let us try to write the condition now. R is in the set of natural number and you should choose the set in such a way that this is second sub question. I hope the first question is clear for all of you. So second sub question. So R is in the set of natural number, and under the set of natural number they're telling y is equal to x plus 5. So if y is equal to x plus 5, you need to select numbers in such a way that y is equal to x plus 5, and you have to select numbers where x value is less than 4. So what are the values you can take? Natural numbers, where it starts, natural number is nothing but the counting number, children. I hope all of you know this. So it starts from 1, 2, 3. Only 3. You cannot take 4 because it should be less than 4. So what are the elements you're going to consider here? You're going to take 1 possible. So 1 plus 5 gives you what, children? Yes, 1 plus 5 gives you 6. So I can write 1 comma 6. Possible, children? Yes. Now you can write 2 comma 7. Possible? Yes. You can write 3 comma 8. Now tell me whether this set is reflexive, symmetric or transitive. No, because as we know, 1 comma 1 does not belong to R, and 2 comma 2, 3 comma 3 also does not belong to R. So what we can call it? It is yes, not symmetric. It is not reflexive, right? It is not reflexive. Yes. And check for symmetric, children. You have 1 comma 6. Yes. And 6 comma 1 does not belong to R. Yes or no? You have 1 comma 6 belongs to R, but 6 comma 1 does not belongs to R. Hence what you write? Hence not symmetric, because it is not obeying the condition what we studied in the beginning. Yes or no? Now if you're checking for transitive, just check for transitive, children. Yes, we have 1 comma 6, okay, which belongs to R, and we also have, yes, do we have 6 comma any other elements? No. So you don't have 6 comma 2 or any other element. So you only have this. So you can write 6 comma 2 or 6 comma 3 is not 6 comma 7 or 6 comma 8 or 6 comma 3. That is not belonging to set R. Hence what you can directly write, it is not transitive. So this relation also neither reflexive nor symmetric nor transitive. So this was your second sub question. So I hope these questions are clear. Now let us try to solve. This is your third question where it is neither reflexive nor symmetric nor transitive. Yes, children? Now let us try to solve the next one where R is a relation under set. Look at this. R is a relation under set A 1, 2, 3, 4, 5, 6 as R x comma y, where y is divisible by x. You need to select the elements in such a way that y is divisible by x. Now tell me what are the possible values here, children. Now you see x comma x belongs to R here in this case. It's not like the previous case, correct? Because if you're trying to observe here, just observe this. If I'm going to write this here, we know the condition for reflexive. So let us try to solve in this itself here. I hope these conditions are clear for you, children. Now just observe here. I will write my A is 1, 2, 3, 4, 5, 6. Now you observe 1 comma 1 can be written under the set. Yes, because 1 is divisible by 1. Yes, 2 is divisible by 2, 3 is divisible by 3, 4 is. So what we can write, it is reflexive because all these, it obeys A comma A belongs to R, right, children? So it is reflexive. Now in the previous two cases it was not. Here it is reflexive. Now just observe, if you write 2 comma 4, that belongs to R. Yes, because they have given the condition y is divisible by x. So is 4 comma 2 belongs to R? 4 comma 2? Yes. Can 4 comma 2 belong to set R? No. Correct? 4 comma 2 does not belong to set R, children. Yes. So hence what is the condition? With this, not symmetric. Yes. Is that clear? Understanding this? Yes. Easy? Simple? Now check for the third condition where it is transitive. Now just observe, children. If you take some elements, suppose you consider some elements. We have numbers from 1 to 6 here, correct? Now if you are checking for transitive, just observe under transitive condition what is it? It should be obeyed for A comma B, B comma C and A comma C should be present. Now if you're taking that case, just observe, if I'm taking three numbers, that is x comma y and y comma z. So if y is divisible by x, just observe, if y is divisible by x and if you have z, okay, if you have z that is divisible by y, okay, in this case is it possible to write z is divisible by x, children? Yes, possible. So you can also write z is divisible by x. Hence what you write using these three conditions, it is transitive. Yes or no, students? It is transitive. I hope this is clear, children. It was an easy and simple question. Yes. So we have solved the sub question 1, 2 and 3. I hope all of you understood this, and it is reflexive but not symmetric, but it is transitive. Yes. Is this clear? Yes, because why it is not symmetric? Because x comma y, like you can write y divisible by x, you can't write x divisible by y. Yes, that is the reason. Now let us go for fourth question. Relation R in the set of all integers defined as x comma y, where x minus y is an integer. So they're telling x minus y is an integer. Now see, children, just a clear observation. X minus y is an integer. Relation in set Z of all integers they're asking. So if you take a set of all integers, what happens here? Tell me. In the set of integers, if you take an example, if you take some elements x comma y is also an integer, y comma z is also an integer. What about x comma x, children? Is it reflexive? Tell me, is it reflexive? X comma x becomes what? X comma x is 0 because x minus y they are talking about, correct? So I can write x minus y 0, and 0, does it come under the integer, children? Yes. So what you can write for the first case? Yes. What you can write for the first case, children? First case you can write x comma x belongs to R because x, this is the fourth question what you are solving here. Yes, because x minus x will give you 0, which belongs to set of integers. Yes or no? Yes. Now it is reflexive, right students? It is reflexive. Now next, what are they talking about? They are telling that x comma y, if you take, yes, it is true that x comma y belongs to R, that is x minus y. Correct, children? X minus y will be an integer value which belongs to R. True. Yes, in that case. Now tell me, y minus x, will it be an integer? Yes. Yes, y minus x also will be an integer, correct? So in that case, x comma y belongs to R, y comma x also belongs to R, correct? In that case, it obeys the relation. So I'll write it is symmetric. Yes, students, it is symmetric, right? Yes. Now the third condition. Think, children, if x comma y belongs to R, then x minus y should be an integer. So I'll write here, okay, y minus x, y minus z I'll take, okay, y minus z belongs to R, that also belongs to integer. Now just observe, if you're adding this, you have y minus z. If you're adding these two, you're going to get integers, children. Why? Because you cancel. What are you getting? X minus z, that also will be an integer. That obeys your transitive relation where x comma z also belongs to R. So it is transitive. Right, children? It was easy and simple. Yes, these are very basic level of questions, right? Yes. So we have solved the sub question 4 here. Sub question 4 is complete. Sub question 3 is complete. Sub question 2 and sub question 1 is complete. Now let us see sub question 5. Relation R in set A of human beings in a town. A particular time. This we can solve orally, children. At a particular time given, X and Y work at the same place. X and Y work at the same place. So X and X reflexive, correct. Y comma Y belongs to R. X comma X also belongs to R. So it is reflexive. Yes, yes sir, it is reflexive, correct. Now if you consider about symmetric and transitive, it is reflexive, symmetric and transitive. Take x comma x, it is reflexive. X comma y comma x, yes, they work at the same place. Now if you take x comma y comma x and x comma y again, they are transitive also, correct. If you take three elements also who work in the same place, suppose you take an example, x comma y belongs to the set, correct. Now x comma y works at the same place, y comma x also works at the same place, correct. Now if x comma y works at the same place and y comma z also works at the same place, then tell me, children, x and z also works at the same place. Is that true? Yes. So this is reflexive, symmetric and transitive. Yes, it is reflexive, symmetric and transitive. Now second question, x comma y, x and y live in the same locality. Now if x and y live in the same locality, x and x same, because the same person lives in the same locality, so x and y is true, y and x is also true. Yes. Now x and x is also true, so it is reflexive and symmetric. And take three people, x and y lives in the same locality, y and z lives in the same locality, and z and x also lives in the same locality. Then what you can write, x, y, z, all three live in the same locality. So this is also reflexive, symmetric and transitive. Understanding the reason, children? Yes. So next one, x is exactly 7 centimeter taller than y. This you can think of, children. If x is 7 centimeter taller than y, you can't write x comma x is not possible, so not reflexive. X comma y, if it is possible, y comma x is not possible, because if x is 7 centimeter taller than y cannot be 7 centimeter taller than x. So not reflexive, not symmetric, not transitive also, right, children? Because if y is taller than x by 7 centimeter and you take z who is taller than y with 7 centimeter, then with x and z when you compare, it will be 14 centimeter, not 7. So it is not transitive. So it is not reflexive, not symmetric, not transitive. Yes. Now compare these two questions. It's very funny, but still it's a NCERT question. So x is wife of y. So you can't write x is wife of x. So not reflexive. If x is wife of y, can you write y is wife of x? Possible, children? Is it possible to write that way? X and x not possible because she can't be wife of herself, correct? X and y, is it possible, children? Yes, tell me. If x is the wife of y is the wife of z, that is the possibility that it is possible? No. So in that case, what do you write? This is neither reflexive, nor transitive, nor symmetric. Yes, because it cannot be compared. You cannot take it as transitive also. It is not reflexive also. It is not symmetric also. Right, children? Understanding? Yes. Now, next one. X is father of y. X comma x is not possible. X cannot be father of himself. X comma y, if it is true, y comma x is not possible. But x comma y comma z and z comma x, is it possible? Just think. That is also not possible, because if y is father of x and z is father of y, then z becomes grandfather of x, not father of y. So this also is not reflexive, symmetric, and transitive. Yes, I hope all of you understood all these questions, children. And this is NCERT first exercise of your first chapter, relation functions 1.1, the first question. I hope this is clear and it is a simple question. And like, share and subscribe and share it with your friends, so that in this channel you will be able to get a detailed description as well as a discussion on each and every NCERT question. Thank you, students.